This is a talk about the revolution of digital anatomy and the use of virtual reality. This talk was given in Lisboa in our third Congress of Digital Anatomy. First, some words about the history. You can see on this slide. On the left, Leonardo da Vinci in the 15th century. In the middle, you can see a wax model of the 19th century. And on the right, you can see what we have today. That is a 3D model. The most important point to highlight is that the anatomical dissection is the gold standard for our knowledge. And you can see here Professor Giraud making a painting of the vein after latex injection of the cadaver. The result produced by this technique that we call color segmentation is really fantastic. And you can see here a lateral view of the leg, which is showing different kind of veins, which would be very difficult to recognize without the color segmentation. So, as an introduction, anatomy is a basic science, everybody knows. It's mandatory for medical education, it's essential for medical practitioners, and of course, is mostly important for surgery. But it's going through a... What is this crisis? Why a crisis? Because we have some big issues, the new computer techniques for education, the advances in molecular biology and genetics, and mostly the lack of cadavers. So difficulties of this dissection for ethics or religion reasons, and the bigger number of students willing to study anatomy. This is a reason why the 3D modeling is a very nice tool. It overcomes the lack of cadavers. It is also used to prepare or before cadaver dissection, but not instead. And this is using the virtual reality techniques, which are new educational methods. Also possible to have a statistical analysis of the anatomical variability, which we call computational anatomy. And this is participating on the revolution of surgery, of course. All these tools can be used for planning, training, simulation, and also the technique of augmented reality. So our project since 1999 was to make formation of digital anatomy of the students, and you can see here that since 18 years about, we organize Master 1, Master 2 thesis using digital anatomy. And we created a research unit in the Descartes University in Paris in 2007. We created also a Unesco Chair of Digital Anatomy in Descartes University. What are the reasons of this Unesco Chair, which is the chairman is Professor Delmas, is to spread the use of these new digital tools, and particularly the use of virtual reality, of course, and also to develop partnerships with other universities worldwide to set up a 3D anatomical data bank. You can see here that this partnership was around the world, in South America, in Indonesia, in Africa, and in... So these are the founding members, and on the left you can see Professor Delmas, who is the chairman, and you can see the website dedicated to digital anatomy. The partners of the chair, as you can see here, are all over the world. You can see on the left in the North and South America, you can see in Europe, you can see in Africa a lot, and also in Asia, in Indonesia. Here is the list of the partners, which were the first one were in Algeria, in Argentina, and in Santo Domingo. Overall, we have 37 partners from 24 countries. And with these partners, we organize international congresses of digital anatomy. You see the first one in 2016 in Africa, in Benin. The second is Santo Domingo. The third one was in Lisboa. And the next one is in Mexico. What are the objectives of these works? Is to use the virtual reality as a revolutionary educational tool. The two aims of the chair are first research, that is 3D modeling, mainly for embryology or morphology, and mostly educational purpose. And the first and main tool is a virtual dissection table, and we see the problem with the lack of cadavers, anatomical dissection. You can also use 3D printing. You have another technique using virtual reality, which is immersive reality with the Oculus mask. And lastly, you have also educational, the MOOC on the website for Le. What are the principles and the techniques of this 3D modeling? Two types of modeling we use. The first one is called volume rendering, or VRT. It is coming from digital data of the radiologist, that is CT or MRI, and it is using automatic computation of voxel by a thresholding. And the second type is called 3D vectorial modeling, and this is coming from anatomical slices. So we have to do a manual segmentation. First, the 3D modeling by volume rendering. So the data are coming mainly from patients, from radiologists. Here is an example of a varicose vein patient with a mapping and a skin mapping on the left, and on the right you can see that you have a 3D model of the leg, which is a kind of virtual dissection of the leg of the patient. And here you can see that you can turn around the leg. You can see the varicose network. You can also modify the transparency of the tissues and see inside the muscle. And you can see here the muscular veins. You can zoom, of course. You see here the gastrocnemial veins, which are inside the muscle, which are joining up in the popliteal vein. And you can remove all the muscle and turn around and study all the anatomy of the patient. This is virtual reality, and this is virtual dissection of a living patient to make a surgical planning before an operation. Here you can see the lower leg veins and the lateral perforators. And at the bottom, you can see the foot pump and the lateral plantar veins. Another example of virtual dissection is a young woman with a left iliac thrombosis presenting a May-Turner syndrome, that is a post-thrombotic syndrome. You can see the dissection here, removing the skin. You can see the superficial network here. And then you can see here the sump of the iliac and the collateral circulation, which is here the superficial epigastric veins, the pudendal vein, producing a left to right collateral route. And here you can see more in detail the femoral vein And the big vein which is going here is the obturator vein, which is joining the hypogastric vein in the pelvic area. Here you can see the imprint of the artery, which is stenosis of the iliac. And here you can see the sacral plexus and the rear. So second kind of data is 3D vectorial reconstruction. It is coming mainly for anatomical or histological slices. So it's not digital data. The main aim of those is education, and the objective is to build accurate 3D model to be used for virtual dissection. You can see here an example of the skeleton of the Atlas model, and you can modify, you can add the arteries, you can add the nerves, you can make a lot of things, you can cut the body, you can modify the view, you can see the organs. You have more than 1,500 elements. Here is the venous system. And you can make a virtual dissection, and you can have the name of this anatomical element. Here is another example of the heart and vessels from the anatomical atlas. Here another example of the head and neck vessels. Here the brain and the veins and arteries. With this polygon, you can remove the brain, can see inside. Can see the thalamus and the ventricles. And the longitudinal venous sinus. Here you can see the presentation of this virtual dissection table, which is a huge 3D screen, which is a touch screen, and you can drive it only with 3 fingers. And you have buttons, and you can play with the model, make a section, and have the name of the elements. Another example of this very nice tool is the 3D Embryo Atlas, which was set up by Amsterdam University. And you can see an example here of a small embryo of 2 months. And the same way you can handle, you can interact, you can select different systems, cardiovascular system. You can have the name, umbilical vein, left atrium, cardinal vein, cerebral arteries, can have the alimentary tract, and select structure. You can have the skeleton, you can add the skin, can have the urogenital system, gonad, metanephros, and you can have thyroid, thymus, lung, and nervous system. You have also other tools for education of simulation. And these tools are mainly models and tools of virtual reality. The 3D printing models could be very interesting for learning, and you can see a set of those objects, anatomical objects, which are 3D printed in color, including the skeleton, including the heart. You have also synthetic cadavers, which could be available. You see here the upper limb with the nerves and the vessels, the lower limb. But indeed, the best solution is a plastination model. But this is very, very. You see here the catalog of Blueray, which is a Chinese company providing a lot of models, which are real models coming from China. This is but expensive.
Mais sans les pieds.
Another point, also interesting technique, is immersive reality provided by Oculus glasses. And this is a very powerful education tool, very impressive, enhancing the learning effect of the lesson. Another example, HTC from Basel.
Walk around, they can grab the object, reposition it, they can also change the size, zoom in, zoom out, rotate it at will, so that they have the most comfortable and best view of the scene. As an additional option, we also gave them a cutting plane. This cutting plane can be used to either come through the volumetric data set, for example, cut open the skull or the rib cage for a better view of the scene.
Another example is HOLOLENS with a virtual art.
Okay, so you can kind of look at this ginormous heart and look into the function of it by cutting into one of the chambers and actually looking at a valve and how they operate. Probably a view that would be very difficult to do without something like this. So do things like rotate it, rotate, spin it around.
You have voice commands.
Stop.
And you have also gesture commands. So in conclusion, all these virtual reality techniques have a major interest for research, but the most important revolution of this technology is educational, and the new educational tools of the 20th century, mainly for anatomical learning and teaching, but also that can be used in surgery, optimized by 3D and by 3D modeling, the pre-op planning, the simulation, virtual training, and augmented reality. Thank you very much for your attention.